I'm going to take a little bit of a risk in this session, which is I'm going to talk about technology, and I'm going to try and use a piece of technology during my talk, which is probably going to mean that I put the evil eye on it and it's going to crash horribly and we'll have to go analog. But what I would like to do is to interact a little with you in the audience, get a little bit of data from you, see what you're thinking about artificial intelligence and art. Can you distinguish AI art from human art? So if you have a smartphone or a device that you can log on to online, what I'd like you to do is open a browser and just stick in this particular address. It's a piece of software I've been using from a company called Glisser. It's quite fun. I can interact with you. You can take the slides away at the end as a PDF. You can send me a few questions as well. So the address is glsr.it/creativity-code. And if you don't have a smartphone or don't want to get involved, don't worry, it shouldn't spoil your enjoyment, but I'd like to get a little bit of data from you to explore what you might be thinking as an audience. So I'm going to be talking about artificial intelligence, and I think the advances in artificial intelligence over the last few years have made a lot of us worried about whether the jobs that we do today will be jobs there in the future. But I think there is one realm where we do feel that is kind of uniquely human, or maybe also Neanderthal if you came to Alice's talk just before me, which is creativity and art. Creativity is surely an expression of what it means to be human. So when AI has taken all of our rather mundane jobs, we can sit back, compose pieces of music, paint, write novels and poetry, content that AI couldn't get anywhere near us in such a creative realm. Actually, as a mathematician, a lot of people think that surely mathematics is one of the first jobs that AI will be very good at, because after all, AI is just implementing code, which is algorithms, which is mathematics. It's doing mathematics. I think a lot of people think that as a research mathematician in Oxford, what do I do all day in my office? I think a lot of people think that I'm just doing long division to lots of decimal places. And if that was true, certainly a computer would have put me out of a job a long time ago. But actually, I think that mathematics is a much more creative subject. And creativity is a word I use quite often as kind of my protective shield against why a computer will not be able to do mathematics. It requires a lot of intuition. I sort of think of a mathematician almost as a storyteller. My story is about numbers and geometry, but I want to tell a story to my fellow mathematicians in Oxford or across the world that takes them on an exciting kind of journey. So I think that mathematics for me has always been a creative subject, and so I felt, well, surely that's not something a computer can do. Actually, during the 90s, I got a lot of people saying, oh, surely now computers can do mathematics, because if you remember, that's when a computer first beat a human, the world champion at the game of chess, Garry Kasparov against Deep Blue. Eventually, he crumbled, and Deep Blue was able to beat humans. But I was never too threatened by chess, actually. A lot of people compare doing mathematics to like playing a game of chess, because there are kind of logical moves you make in mathematics, like the moves that a chess piece can make. There's a kind of end game that you're aiming for, the end of a proof or the end of a game. But actually, chess gets much simpler as the game goes on, because pieces get taken off the board. So it didn't have the kind of same complexity as I thought that mathematics did. And there's always been another game that we mathematicians regarded as much closer to what it means to do mathematics, and that's the ancient Chinese game of Go. If you go to any maths common room, you won't find chessboards around. You'll find this 19 by 19 grid with black and white stones. And to play this game, it's quite a simple sounding game. You just have to put stones down in your color, try and surround your opponent's stones before they surround yours. And this is a game that if you talk to any Go player, they always talk about not really knowing why they're making a move, that it just felt intuitively right. It's a game which, as the game goes on, it actually gets more complex, because more and more stones get put down on the board. And more as you play deeper into the game, you have to use a kind of sense of pattern recognition, looking at the patterns that are emerging on the board. And it's quite hard to articulate sort of why you're making particular moves. And that idea of pattern recognition is very close to mathematics, because I often call a mathematician a pattern searcher. We require a similar sort of intuition for pattern to be able to make progress in mathematics. And it was the fact that a Go player finds it very hard to articulate why and how they're playing, which meant that actually this game has always been very difficult to write code to get a computer to play. And traditionally, computer scientists have always said that the game of Go will be a game that will be almost impossible for many decades to come to be able to write code, to be able to play at even an amateur level. For years, any app you bought to play Go was pretty useless. It would be very easy to beat it, even for a sort of beginner. So there was a little surprise a few years ago when a company here in London, DeepMind, said that they'd actually developed a piece of code that they believed could challenge the world's best at this game. The world's best at the moment is a Korean player called Lee Sedol. And they believed they had a piece of code that they developed which could play this game at an exceptionally high level. Lee Sedol was totally dismissive of this because the code that appeared up to that date could get nowhere near an amateur, as I said. He said, I'm going to be able to demolish this piece of code 5-0 in the match that we'll play. Now, what had changed that meant that DeepMind felt that they could develop code that could play this game at such a high level? Well, there's been a real kind of phase change in the way that we write code. In the past, code would be written in a very top-down manner. We would have to write lines of code which would tell the computer or the machine what to do. If this happening, then do this. And we would really have to know what we were doing in order to be able to tell a machine or a computer to do it. But that has changed now, and you've probably heard of this thing that's been talked about quite a lot now in the media, the idea of machine learning or deep learning. This is really code being written from the bottom up. This is code which is allowed to change and mutate and learn as it gets things wrong. I think as humans, we learn best. I learn best, certainly in mathematics, when I get something wrong. And then I try and understand, well, why did I get that wrong? My best learning moments are through failure, in fact. And so what this piece of code does is that it's able to play. And when it fails to win it at a game, it analyzes, well, what changes in my code would mean that I would have won that game last time. So there are lots of parameters, and it can write new lines of code in there, ask new questions of the patterns emerging, such that as the process of learning goes on, the code is actually developing, becoming much more complex to such an extent that by the end of the learning process, the person who wrote the original code really hasn't got a clue what the code is how the code is making its decisions. So what DeepMind did was to take all the human games that have been played, and a lot of them are available online, and the piece of code, AlphaGo it's called, started learning on these human games. Then it ran out of the human games and started creating its own synthetic games. So it started playing itself. And through that learning process, it could see which versions of itself were much stronger, and it could kind of accentuate those parameters in that bit of the code and downgrade the ones that weren't working. And so after this learning process of looking at human games, then generating its own games, AlphaGo felt, or DeepMind felt, that AlphaGo was ready to challenge Lee Sedol. They played over 5 matches in Seoul, and Lee Sedol did not win 5-0. He lost 4-1. And he regards actually that one game that he did eventually win as the most important win of his whole career. Now, it's not unusual to see computers doing things better than humans can, machines doing things better than humans can. We got quite used to that. Chess playing algorithms. My computer can do calculations faster than I can. Machines can fly, I can't fly. Cars can go faster than I can run. So perhaps not so unusual that now we have a piece of code that can play this game at such a high level. But for me, there was something more significant that happened during those games. And that is because I saw this piece of code doing something which I regard as being creative. And this happened in the second game against Lee Sedol. So in the first game, Lee Sedol actually tried to disrupt its learning by playing a very inhuman game. He went against his usual style of play. But AlphaGo was up to this, beat him in the first game. Then in the second game, Lee Sedol was playing white. He put a stone down on the 36th move of the game. He was already exhausted by 36 moves, decided he needed a break, went up to the top of the hotel in Seoul, smoked a cigarette. We humans still need nicotine to stimulate our creativity. The code doesn't need nicotine, it just sat there. And then after a while, it asked the human player. Interestingly, we still needed a human to pick up the stones out of the bowl to put them delicately onto the table because, that's quite, many years of evolution has developed this amazing machine called a hand, and we're already still finding that quite difficult for a robot. So there was a human player putting the stones down, and the human player, AlphaGo, asked the human player to put a stone down on the 5th row in from the edge. And I've marked this stone, this black stone, with a little white circle. Now, I watched these games live on YouTube obsessively because I realized that if this code was going to be able to play this game very well, then probably it was my job that was next in line. So I was really rooting for humanity as I watched these games online. And I remember the moment this stone got put down because there were commentators online, Koreans, Americans, Russians. They all gasped at this moment and went, AlphaGo has made a huge mistake. Because early on in the game, your Go master teaches you that you should only put stones down on the first 4 rows in from the edge. This is where early competition for territory happens, on the kind of very extreme edge, and then the beginnings of creeping into the center of the board. And your Go master would say, if you put it on the 5th row, that's considered an incredibly weak move. Your Go master would say, slap your wrists and tell you to think again. And so when the commentators saw AlphaGo making this incredibly weak move, as they thought, they said, well, Lee Sedol will be able to win the game from now on, because that's just such a weak move. Lee Sedol came down from his cigarette break, and it was amazing seeing his double take. I mean, he was utterly surprised by the move that AlphaGo had suggested. But he was a little bit more suspicious because he'd already experienced how good this piece of code was in the first game. And he thought for some time before he made his next move. As the game went on, it wasn't clear how important this move was going to be. But as we went deeper into the game, more and more territory began to build from the bottom right-hand corner of the board. And it turned out the person who controlled this building territory was the one who put that stone down on move 37. That black stone won AlphaGo this huge swathe of territory and the game. Now, for me, that move passes 3 tests that I'm looking for if I'm going to call something creative. This is actually 3 tests that I learned from a cognitive scientist called Margaret Bowden, who I was on a committee with at the Royal Society. We've been looking at the impact that this new technology is going to have on society in the coming years. Actually, Demis Hassabis was also on the committee. He was the creator of DeepMind and one of the members of the team behind AlphaGo. Margaret Bowden has this nice definition. It's quite a useful, user-friendly definition. I think there are many definitions of creativity, but I'm going to use this one throughout the talk, and I'll mention perhaps a few more at the end. But she's been thinking for a while what computers, or actually she calls them tin cans, what these tin cans might or might not be able to do. So she says something should be creative if it's new. Well, machines can make lots of new things, and we can judge that quite objectively, novelty. But they should also be surprising and have value. Now, surprise and value are much more subjective qualities. I might value something like a poem I've written, and you won't value it at all. And value changes from one culture to another, one period of history to another. So AI is going to have to learn what we regard as having value, what we regard as something which surprised us. But that's the power of this new technology of machine learning, that it can take data that we give it and kind of sniff out the quality of that data to be able to reproduce more, or perhaps produce different sorts of data which pass those qualities. But for me, you see, that move 37 in Go certainly passes these 3 measures. It was a new sort of move. It certainly surprised the commentators because of that gasp that they all made. And ultimately, in a game, you can judge value very cleanly because that move really did win AlphaGo the game. And that's why games are very nice to start your exploration of AI, because they're kind of nice closed environments where you can judge perhaps value by winning or losing a game. For me, why I think this is really creative is because if a human had written that code and seen a line of code in saying, okay, play on the 5th row in, they would have cut that piece of code out. They would have said, no, that's a bad move, a weak move. Any code by a human would have actually denied the codes the possibility of playing that move, because we considered it a very weak move. So the fact that this piece of code developed enough to be able to challenge and say a move that would have been written out by a human, I think it really does show that this is emerging out of the learning process of the code, and it hasn't been put in there by a human. And for me, the exciting thing about the role that AI might be able to play in our own human creativity is that we thought we'd found the kind of optimal way to play this game. We sort of reached the height of Go playing, the height of this mountain, and we believed this was the best way to play. But this piece of code has shown us that actually that peak is not the highest peak in the landscape, that there is in fact an even higher peak across the valley. Somehow there was a fog around us that we didn't know about a higher peak, and AlphaGo has cleared that fog and revealed to us that there is an even superior way to play the game. And this is actually a kind of image that ran throughout the whole of this book that I've just recently written about the possibility of AI being creative. That in some ways at the moment, the best thing it can do for us is actually to help us as humans to be more creative. I think that very often as humans, we kind of get stuck in our ways, stuck in particular ways of thinking. I know this with my mathematics. There are certain things that I know, strategies that I use that work quite well, and then I'll repeat those behaviors over and over. And I can end up tending to behave a little bit too much like a machine, because I just repeat behaviors over and over. And what's exciting is that AI, the stories I've investigated in this book that I'm going to tell you about, are actually helping us to kick out of those kind of mechanical ways that we can get stuck in, and actually pushing us perhaps to behave more creatively as humans again. So the AI is helping us to behave less like machines and more like humans. So this has been the kind of journey of this book, The Creativity Code, which I'll be happy to sign some copies after the talk. Because I was interested, if AI can be creative in this realm of a game, where else can it be creative? Can it be creative in the realm of visual art or music or maybe the written word or even my own subject of mathematics? And it's very interesting because one of the first people to consider the power of code to make machines do interesting things was Ada Lovelace. In fact, we celebrated Ada Lovelace Day this Tuesday. She's celebrated really as the first computer coder because her mother took her along to see this machine that Charles Babbage had made to do calculations. And she became very intrigued that this machine could do much more interesting things than just long division. And she started to write down kind of instructions for the machine that suggested other things that it could possibly do. And those instructions that she wrote down, we now regard as the first example of computer code. And she was already speculating in those notes about how far the machine could go. Not just mathematics and science, but she wrote, the engine might compose elaborate and scientific pieces of music of any degree of complexity or extent. And of course, mathematics and music have a lot of close connections. A few years ago, I was here at New Scientist Live with a composer, with a piece that we created together, combining mathematics and music. So interesting that Ada Lovelace chose music as perhaps where code might be able to be creative. But she offered a word of caution about this creativity. She wrote, "It is desirable to guard against the possibility of exaggerated ideas that might arise as the powers of the analytic engine. It has no pretensions whatever to originate anything. It can do whatever we order it to perform." And I think that's been the thought in the past, that if a piece of code is creating music, then it's not the code that's the creative one. It's the human who wrote the code that told the machine to produce the piece of music. So in the past, when code was written in this very top-down manner, I think that Lovelace's belief was probably true, that really it's the human who writes the code who tells the machine to do something who's the creative one. But I think that's what's changed over the last few years, with this new style of code which is actually changing, mutating, learning, developing, becoming something so much different from the original code written by the human. There is suddenly the possibility to put a little bit of distance between the code and the coder, such that perhaps it's the code you should call being creative. After all, that move 37 was not coded in by a human. It was learnt by the piece of code as it played games. You could say, well, it was the clever code that allowed this machine to learn. That's certainly true. But I think, you've got to think in some ways a bit like a parent and a child. The child's a product of the DNA, but a child's learning process, at some point you don't credit the parents as the creative ones when a child grows up and becomes a great living artist. Now, you've probably heard of something called the Turing Test. Can a computer pass itself off in an interaction online with a human, and the human can't tell whether it's talking to another human or to the computer? Well, there's now an idea of something called the Lovelace Test, which has been suggested. And this is the challenge of whether a machine could ever originate a creative work of art such that the process is repeatable. So this shouldn't be just kind of random data coming from the outside which is producing the surprise or something new, or a hardware error, for example. The actual output should be a product of the code. The code should sort of know what it's doing. It shouldn't be just combining with some random input. But here's the challenge, that the programmer, the person who wrote the original code, cannot explain how the algorithm actually produced its output. So how well is code doing at being creative in kind of more artistic realms? Well, I'm going to start with the visual arts, because that's actually where machine learning has been incredibly successful. I did a program for Horizon a few years ago when it was a Turing anniversary, and we made a program about artificial intelligence. And at that time, these kind of new techniques hadn't really exploded onto the scene. And I remember a lot of the people I talked to said, well, computer vision is a long way off. Getting a computer to look at an image and say what's in that image is almost impossible. How can you write a piece of code which is going to question the image? A piece of code very often looks pixel by pixel. The human brain is amazing over its period of evolution to be able to look at a picture and immediately decode the story behind that picture. So it was felt that almost impossible to write code to recognize what's in an image. But that's something that has been perfect for machine learning. So you give it lots of images of dogs and cats, and you label them up as dogs and cats, and it starts finding the questions to ask about those images such that it can distinguish the two. There are lots of images of dogs and cats online, so some of my cats are online. So lots of digital data for it to learn on. And that's one of the key changes here, because actually machine learning is quite an old idea. What has changed is suddenly the machine learning has never had a kind of environment to learn in. Suddenly the rich digital world we live in means that there's a place for it to play. And also processing power has got to such a high level that it can actually cope with large swathes of data. So now, actually, if you give, for example, Google image recognition software one of your photos, it's amazing how accurate it is in identifying the key things that are in that image. If you've never done it, I suggest you just load something up if you're not worried about your data going to Google, and ask it, what do you see in this picture? And really remarkable. So I've looked at the visual world, first of all, because if it's successful in identifying images, how good is it at actually creating images? So here's your first challenge. I'll send these to your mobile phones now, so I'll go back to these two here. So you should now have on your phones 2 paintings. And what I'd like to know from you is, can you sniff out which of these paintings is actually not created by a human? So you can probably recognize who the painter is here. This is Rembrandt. Rembrandt has a very specific style of painting, beautiful use of light, the way his characters sit. There's kind of just a sort of, it seems very characteristic. So this piece of machine learning that was developed in Holland took all of Rembrandt's portraits, and he did quite a lot of portraits, so quite a lot of data to analyze, and looked at the particular features, the way he draws faces, that use of light, and then produced a new Rembrandt based on this learning process. So that's what I want you to try and sniff out. Can you see, people often talk about the Rembrandt shudder. If you're in front of a Rembrandt, there's somehow that connection to the soul of the person whose portrait is being taken. It gives you that kind of fizz. Is one of these not giving you the Rembrandt shudder? Okay, so let's see whether I can get some data coming up. Ooh, that's quite Brexity. Right, you're obviously not quite, oh, okay, so it's a little, now let me just interpret this for you, because pie charts go clockwise. So actually the red, rather frustratingly, corresponds to the image on the left. And the yellow corresponds to the image on the right. So there's a little bit of an edge for the image on the left at the moment. I tried to write a piece of code to actually swap these over, but I failed miserably. So we're going to have to go with this kind of slightly skewy. So okay, a little bit of an edge for the one on the left. Anybody like to say why they thought the image is on? Yes. So why did you feel that you voted for the one on the left? Did you, as the AI one? The one on the right was signed. Well, if I was going to fake a Rembrandt, I would sign it. Okay, so the man at the front has voted for the one on the left because you thought that was too good. I think it's better, and so he's kind of doing some reverse kind of process. It looks better, and therefore it's probably not, so yeah, you're trying to second guess me here, I think. And yes, the other one is actually signed. So, okay, well, which one was it? You're still about 60-40, so you're in fact right. It was that one on the left is the artificial one. But I think, the fact that you were 60-40 meant that quite a few of you were taken by the one on the right as the AI one. It's actually quite difficult because so many Rembrandts are well known. To try and find a Rembrandt that you probably had not seen before meant that actually I had to choose rather a shit one. So I think you're absolutely right. I think this is actually much nicer. But I think, it's pretty convincing, pretty good. And actually a Rembrandt expert who kind of hated the idea of machine learning creating another Rembrandt came along to criticize the project. And I've shown you a 2D image, but they actually made this as a 3D image. So if you've ever seen a Rembrandt, the way he puts paint on the canvas is an important component of it. It's really layered. It's very tactile. And so they'd even analyzed the style of the paint on the canvas and analyzed this, and they 3D printed the image. And so the person who came along to criticize it said, well, the only thing he could find to criticize it was the style of paint on the canvas was 20 years earlier than the actual style of the portrait. So the machine learning team felt, well, we've done pretty well if that's all that it can be criticized for. But you might say, what's the point in this? This is just pastiche. This isn't creativity. This is just doing more of the same. Well, I think there is a point because the power of machine learning is often to pick out new patterns in old data. Not with Rembrandts, but there's an example of Jackson Pollock where algorithms applied to Jackson Pollock have revealed that what he is doing with his drip painting is something very specific and mathematical. He's actually creating fractal geometry on the canvas, and you can even kind of measure the kind of dimension of that fractal and sort of classify periods of his painting. So machine learning applied to the old can give us new insights. But I agree, in some sense, not so exciting to do sort of old art. And in fact, many critics really hated this project. This is my favorite art critic in The Guardian, Jonathan Jones, who hates anything to do with artificial intelligence. But I do love him. He writes so well. About this Rembrandt project, this is his belief. What a horrible, tasteless, insensitive, and soulless travesty of all that is creative in human nature when technology is used for things it never should be used for. But frankly, anyone who wears a shirt like that, I really don't trust as an art critic. But yeah, so he has a point. But we want something new. We want to be taken somewhere new, not to old masters. So what about new styles of painting? So here's your next challenge. So I think I've just sent those to your phones. So 4 of these paintings are done by a human. 4 of these paintings are done by artificial intelligence. I want you to choose the paintings that you think are done by artificial intelligence. Can you sniff out the ones that you feel are artificial? So hopefully you're succeeding in sending those to me. Let's see what you're thinking. So again, remember the red corresponds to the images on the left and the orange. So again, a little bit of an edge for the ones on the right as the artificial ones. I was going Brexity again, quite close, but yeah, that's 55-45. Who voted for the images on the left as artificial? Yes, sir. Why did you think those were artificial? So the gentleman in the front felt the ones on the left were a bit too symmetrical. So, and that symmetry is something that a piece of code might like. Who voted for the ones on the right being artificial? Yes, what was your feeling? So what she was saying is that the computer might pick up the fact that we humans like color. And there's a lot of color there, so it might have learned on the fact that we like color. It's interesting, I think another kind of thing that people pick up on is the complexity of those, and perhaps, and sometimes for people that means that it's human because of the complexity, or sometimes it can swing the other way. So let's see how you're going on those. Oh, wow, there you go, that's almost split down the middle after those two. Okay, that is 50-50, so which one is it? So it in fact was the more complex ones. So the images on the right are the ones done by AI. These were shown at Basel Art Fair. And the visitors to the gallery were not told that there was any computers or code or AI involved. They just assumed they'd all been done by humans, and they were asked to just give their response to the different pieces of art. These 4 on the right elicited a much higher emotional response from the people who went to the gallery. And when they were then told that, well, these are actually being created by a computer, I think many of them felt very cheated. I mean, wouldn't you feel cheated? So why did they feel cheated? Because I think the point about our art is that we're hoping that we're connecting with another human being, another human's way of seeing the world. And if it's just a piece of cold code, then we feel somehow cheated by that. But on the other hand, if I told you a joke and you all laughed at the joke, and then I told you, well, that joke was actually created by a piece of code, that doesn't invalidate your laughter. So I think you have to go back to why are you feeling like the source of the actual creativity is important in that reaction that you had. And again, remember, as the woman in the front said, this piece of code is learning on what we like. We like colors, and it's learnt on our emotional world. In fact, the story of this, the code behind these is quite interesting, because this isn't one piece of code. It's 2 pieces of code kind of working together, or maybe almost in competition with each other, like a game. It's something called a creative adversarial network, which is a very specific example of something called a generative adversarial network. And this adversarial side means that the 2 are sort of competing against each other to try and reach a goal. So the first algorithm takes all of the art of the last 1,500 years, and it learns particular styles of art. So it learns to be able to classify them. So if you give it a painting, it can identify it as pointillist or cubist. So it sort of becomes an art historian. And then it's tasked with making something which breaks the mold of those styles. So it has to try and understand those styles and break the style. But it can't break it too far, because it's got to know what we regard as art. So it's learned a kind of large parameter space of art, but it's also learned what specific styles are. It's trying to create something which is still art, but not in a style that can be recognized. The discriminator algorithm is actually the one who says, no, that piece is still too close to a style that I recognize. Or alternatively, it's saying that is way out of our comfort zone of what we believe as art. And it's the 2 working together, making choices, discriminating, that ultimately came up with these particular paintings. And I think that's interesting, because that captures, for me, a quality of the creative minds that is something actually Paul Valéry, a French poet, sort of once said, it takes two to invent anything. The one makes up combinations, and the other one chooses. And I certainly find that in my own kind of collaborations, creatively trying to make mathematics. I have a collaborator in Germany. I'm the kind of bubbly, creative one trying lots of things out, and he's the discriminator algorithm, kind of shooting things down. And then I have a collaborator in the Middle East who we swap roles. So he's kind of the good cop trying lots of things, and I'm the bad cop sort of shooting things down. And I think a lot of creative artists will talk about, trying stuff out, but then being quite judgmental about what is good and what isn't. And actually, I did another horizon about intelligence, and we were trying to discover what about the human brain gives rise to intelligence, kind of a silly question in some ways, but we went up to see an interesting guy in Liverpool, Birkenhead, who he'd had a stroke. He was just a builder, and after the stroke, he just could not stop painting. Suddenly, he'd never painted in his life, and he just had this sudden urge to paint. And we went into his house, and it was like the Sistine Chapel. Every single surface was covered in paint. It wasn't good painting. So we asked a neuroscientist, what had happened here, and by analyzing, they'd done some scans, and what they think had happened is that in our brains we have a bubbly creative side and a kind of inhibitor, and the stroke had knocked out the inhibitor and left just this kind of bubbling creativity one. And I think sometimes our inhibitor is too strong, which kind of closes our creativity down. So it's about getting these two together, and that's sort of what's being captured in this particular algorithm. But the most interesting visual art project I saw on my journey of writing this book actually is not producing art that I think is particularly great art, but I think goes to the heart of why we started doing art in the first place. Why humans 40,000 years ago, Neanderthals, as Alice said, maybe 60,000 years ago. Why do we start having this urge to make art? I think it was because possibly, my conjecture is that maybe this is the same time that consciousness began to emerge in these species, and that we needed to share our way of seeing the world and see whether it's any similar to the way somebody else sees the world. And so now we've got a kind of new, well, it's probably controversial to say it, a new species emerging, AI. And the code that's emerging is becoming so complex because it's writing itself that the original coder doesn't know quite how it's making its decisions. And so we need tools to examine what I'm going to controversially call the subconscious of the code, the way that it's thinking, seeing, making decisions. So in the case of the Google image recognition software, it's very good at identifying what's in an image, but what's it really seeing? So Google had this idea to kind of reverse the whole process. Give it an image which doesn't really have anything going on in it, and then ask it just to accentuate, what do you see inside this image? A bit like when you look at the clouds in the sky during the day, and you'll see images like a snake or something. So it just asks, what are you seeing inside here? So, for example, it gave it this image of some jellyfish, not very distinct image, and it was just asked to accentuate anything that was in the image that it saw, sort of over and over again, until this emerged out of this image. Wow, indeed. It's extraordinary, but this gives us some insight into what it's seeing and what it's learnt on. It's learnt on lots of images of animals, of skins, of faces, of eyes, of mechanical things. There's a strange kind of mechanical thing in the center there. It helps us to understand the learning process. It's kind of psychedelic, rather kitsch art, but this to me is one of the most interesting things because we're getting insight into the way the code is learnt. Take this image. It was given some grey pixels to look at, and it started to see dumbbells appearing inside these grey pixels. But when it started drawing the dumbbells, it always attached arms to the dumbbells. Why? Because it had never seen a dumbbell not held by a strong man or woman. It thought that a dumbbell was an extension of our anatomy. And so here we get a way of seeing bad learning going on, that we now know it's never seen an image of a dumbbell on its own. And this is really important going forward because biases are beginning to creep in to the algorithms that push and pull us around in our daily lives because of bad data it's been given. I did an event last year at Wired with a roboticist from MIT Media Labs. She described this story where some robots got delivered to her lab. They had some visual recognition software so you could interact with the robots. But when she went in front of the robots they would not recognize she was there until she put a white mask on. She was a black woman, and she then started to examine, looked under the bonnet of how this visual recognition software had learned to see people and understood that it had only ever been given pictures of white males to actually learn on, so it hadn't recognized. So she started something called the Algorithmic Justice League, which I think is a great name for an organization, to try and sniff out these bad biases, because we think code is somehow neutral. But it isn't, because of the learning that it can go through. I like this quote from Paul Klee. He said, art does not reproduce the visible. That's not interesting. It makes things visible. And here we're making visible the decision process of the code. Marshall McLuhan once wrote, art is a distant early warning system that can always be relied on to tell the old culture, which is all of us lot, what's beginning to happen to it. And I think that's what's exciting, that it isn't just a kind of airy-fairy project. The art that AI produces can give us amazing insight into the way the code's thinking. Okay, what about music? Ada Lovelace speculated it might be good at music. There are lots of stories of music in the book. I'm going to just pick out this one, which I think is quite fascinating. This is a jazz musician that had a piece of AI that learned on his particular style of playing, and the AI learnt the kind of riffs that he was doing, and then they did a concert together in a kind of call and response. Again, intriguingly, it was the audience felt that the AI was the human one because it was doing more complex things. It was pushing the boundaries. And it certainly was pushing the boundaries, because Bernard Lubat's response was, the system is showing me ideas I could have developed, but it would have taken me years to actually develop. It's years ahead of me, yet everything it plays is unquestionably me. He recognized that it had learned on his style and just pushed the boundaries. So again, here we see the role that AI may play for a creative. He got stuck in his particular style of playing, and the AI pushed him to actually see, with his sound world, there were still exciting things he could do. Okay, what about the written word? I thought the written word would be a place that there's so much data that AI might be very good at creating kind of written text. In fact, one of the first things that computers actually did was to write text. This is the Manchester Universal Computer that Turing developed up in Manchester after the Second World War, and they were rather perplexed when these kind of love letters from the machine started appearing around the lab. And they discovered after a while that one of the team had written a template and was using a random number generator that Turing had just recently developed to fill the template with words of love. But this kind of small form prose is actually somewhere where AI is quite successful. So, for example, poetry has very nice kind of structure that it can learn, patterns inside there. Poems are often quite sort of leave a little room for creativity of the reader. They can be a little bit gnomic, so a little space maybe for AI to be able to allow you to bring your creativity to a reading. So I've got 3 challenges for you, 3 poems. And I want you to see whether you can sniff out which poems are written by a computer and which are written by a human. Okay, so we're going to play bot or not. Can you see which one is not human? Okay, so here's your first one. I'll send this to you so you can start voting on it right away. So you've got to choose whether you think it's a bot or a human. I won't read it all, but mortal my mate, bearing my rocker heart, warm beat with cold beat company. Shall I earlier or you fail at our force and lie the ruins of rifled, once a world of art? Okay, so what are you thinking? Is that a human or is that a robot trying to communicate to us? Let's see what you're thinking. Well, overwhelmingly going for a piece of code having written that, so that's kind of 90%, 87%. Okay, right, so you think that's code. Here's your next one. Okay, this is even quite difficult to read. There are smallenesses, I'll send it to you actually so you can start voting on it. There are smallenesses of plasticide reaction, of real time, of packs, of displaced exclusionary hurt, of powerlessness, magazine fired non-dignified as head fatty implied internalized violence, of frozen helplessness, of white chalula. Okay, so is that a computer writing or is that a human writing? So how many levels am I messing with you? Because that clearly looks like a bit of code, but okay, so he's clearly human because, oh no, but maybe he thinks that, so you've got to try and work out how many levels of bluff. So, okay, so most of you are thinking just one level of bluff looks too much like code, so it must be a human, isn't it? Okay, so I'm not going to reveal the answer yet. Here's your final poem. I'll send these to you so you can vote bot or not. Imagine now the dark smoke, awakened to fly all these years to another day. Notions of tangled trees, the other side of water. I see it is already here. Sequences of her face, see it is shared, and old friends past their dreams. Okay, so you've had one bot, one human. So yeah, let's see what you're thinking about this one. Okay, so a little edge for bot. So remember the red corresponds to the thing on the left. So a little bit edging for bot. Okay, so you went bot, human, bot. Okay, so the first one. Well, poor old General Manley Hopkins is going to be turning in his grave that 90% of you thought it was written by a piece of code. But I must say, I chose Gerald Manley Hopkins because I've never understood any poem that he's ever written. I mean, you know, if you read that poem, it doesn't seem to make any sense at all. He seems to be smoking something. So, yes, you sniffed out that the second one looked too much like code to be code. And this is a young Australian poet called Mez Breeze who's exploring the fact that code has a sort of poetry to it. So that's actually two humans. So the final one, which you did get 60% of you, is actually something called the Cybernetic Poets, which Ray Kurzweil talks a lot about the singularity when computers are going to take over. And he got this piece of code to learn on styles of poetry, Keats, Yeats, Eliot, Tennyson, and then kind of did fusions of these poems. So small form, it's doing quite well, and because it's quite small and you have to bring your own creativity, it's quite hard to tell. So small kind of prose and poetry doing pretty well. In fact, I got a piece of artificial intelligence to write 350 words of my book. And to date, nobody has been able to identify which passage has been written by AI, including my editor at Fourth Estate, which I find deeply depressing, because I think it's so obvious, it's so badly written. It's like, what, you mean you can't tell what that's... And in fact, there's a bottle of claret from New College, which I've reserved for the first person who does send the passage that is not written by me. But beyond 350 words, actually AI is having a lot of difficulty writing. There's a very interesting example of a team in America called Botnik, a sort of team of coders and writers, and they love Harry Potter. And they were disappointed there were only 7 volumes when they ran out. So they thought, well, why don't we get a piece of AI to write an 8th volume for us? And so there's so much data, so they got took all of 7 volumes, gave it to the AI so it could learn the style, the actual themes and things like that, and it started to produce an 8th volume. I love the title of this book, it's great. It's called Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. What a great title for a book. Anyway, it starts pretty well. Magic. It was something that Harry Potter thought was very good. Well, that's great. It's already picked up that magic is a major theme in these books. So pretty good going. Leathery sheets of rain lashed at Harry's ghost as he walked across the grounds towards the castle. Well, I think it's a lovely image. Leathery sheets of rain. I don't think I would have ever come up with something as creative as that. It's a pretty good start, but then it really begins to lose the plot. Ron was standing there and doing a kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Ron's Ron shirt was just as bad as Ron himself. So this is the trouble that AI, it produces sentences which locally make some sort of sense, but when you globally put them together, it really begins to lose any overarching structure. And you see this actually in the jazz improviser, because the jazz improviser, it's quite amazing to listen to it for about 5 minutes. But after 5 minutes, the whole thing becomes so boring, because it just doesn't know where it's going. And so that's what's interesting. What I've seen is that although the visual, which is kind of a snapshot very often, anything which requires a time element, AI is having trouble with a sort of long scale sort of thing with time in it. And it's interesting because, again, one has to ask the question, why are we as humans creating art? And actually, quite a lot of the book is about human urge to create and where it came from. And I think it is related to actually one of the greatest problems on the scientific books at the moment, which is the hard problem of consciousness. We don't really know whether our internal worlds are anything like our fellow human beings' internal worlds. Are you experiencing the world as I am? I mean, maybe you're not even, maybe you've just sent a load of avatars along and you're sitting at home enjoying yourselves, and it's just a load of, I mean, some of you are looking a bit zombified, I must say, but maybe that's the light. But just exploring our inner worlds, just us personally. And actually, Carl Rogers, psychologist, talked about creativity, not in that kind of new, surprising, and value, but that it's a tool for us as humans to explore our own inner worlds, to share our inner worlds with other people. And George Eliot wrote about the power of art, that it's the greatest benefit we owe to the artist, whether painter, poet, or novelist, is the extension of our sympathies. Art is the nearest thing to life. It is a mode of amplifying experience and extending our contact with our fellow men beyond the bounds of our personal lot. And I think that's what's kind of interesting, that it allows us to actually get in the mind of the other. One of the things that will be a challenge, you see, going forward is that we would quite like the AI that's developing to understand our own world. And one of the interesting storytelling passages in the book is about a piece of AI. It's called interactive fiction Scheherazade, after the storyteller who tells stories every night to keep herself alive. And this piece of AI learned on the way that we humans tell stories. I used to love these books as a kid. I don't know whether you had them, where you get to choose your story. So you go, turn to page 36 if you want to go into the attic, or page 54 if you're going to go down into the cellar. And I used to love the fact you could construct your own stories. In fact, of course, Black Mirror has now a very modern version of that. Bandersnatch allows you to choose your narrative of the particular way this story is told. When I did the Bandersnatch, I was just desperately trying to avoid killing the father, but it kept on offering me this as, but I was determined not to kill the father. And this piece of AI, with learning on human stories, was then given a similar story to tell. It was given a kind of tree of possible stories, and then, having learned how to tell stories from the way we do it, then told its own story. What was very striking is the story that it told was much more humane, much more human, something that we could identify with, than an algorithm that had not learned on storytelling and just told a kind of random story, which ended up being much more dystopian. So, Ian McEwan once said about the 9/11 disaster, he said, if the hijackers had been able to imagine themselves into the thoughts and feelings of the passengers, they would never have been able to proceed. And this idea of empathy is incredibly important. So going forward, there's a lot of dystopia talked about AI. And actually, I've tried to make this book a very positive book about the way that a collaboration, not a competition. But as we develop AI, we will want AI to be kind of empathetic AI. And I think the art that we produce, if it learns on that, we can hope to create a piece of AI that may be more empathetic. But as that AI develops, I think there's going to become a point when this AI becomes so complex that this thing here will become conscious. I don't think there's any reason, why do we have consciousness? We're just a bunch of atoms put together in an incredible way which evolution has developed to have this sense of ourselves. I think at some point this will become conscious. I don't know how long it will take, whether I think it'll take a long time, but at some point this phone will suddenly say, iPhone think, therefore iPhone am. And I'm going to have to wonder whether it's got an internal world, or, it obviously knows about Descartes, but, does it have an internal world? If it does have an internal world, it's going to be very different from our own. As Wittgenstein said, if a lion could speak, we're not going to be able to understand him. But when an AI has an internal world, if it ever does, it's going to be very different from our own. And I think that it's the art that the AI will produce will be our best kind of fMRI scanner, our best tool for understanding what it might feel like to be a piece of AI. Thank you.